Hello there, algebra class. Hi, Ashley. This is lecture 6.2, all about rational exponents, but I thought I would start off with a quick warm-up, so when I call your name, go ahead and shout out the answers. Let's start over there with Aaron. Aaron, what's the square root of 36? Very good, it is 6. Hey, Jared, how about the fifth root of 0? What's that? No, it's 0. The cube root of 64. Let's go with Haley. Haley, cube root of 64? Very good, 4. Not bad, not bad. Sergey, what do you got for the fourth root of 1? Right on, 1. All right. Justin McMurray, what's the fifth root of 100,000? Come on, this is live. Fast. 1. 1 times 1 times 1 times 1. No, 10. Of course, it's 10. And of course, John, the negative cube root of 27. Oh, God. No, it's just negative 3. All right, so this is a quick warm-up on these radicals, things you may have seen before, but we're going to really dive into detail today. And you definitely need this for geometry, algebra 2, and everything beyond. So what we're talking about, evaluating and simplifying expressions that contain rational exponents. And the big thing that's different today is you're going to see a new way how to write a something written to, I should say, a new way to write an exponent. You're going to take a radical and turn it into an exponent. So recall, this is the radical symbol. It's used to indicate roots. The index is the small number to the left of the radical symbol. So like right here, you would say this is the third root or the cube root. So for example, if you said the third root or the cube root of 8, that would be 2, because what number times itself 3 times is equal to 8? Well, that number is 2. 2 times 2 times 2 is 8. What might look a little different is this way of writing it. So another way to write the nth root is by using fractional exponents. And then I'll show you how to do this on the calculator as well. For example, for any number greater than 1, that's what this b greater than 1, if you took the square root of it, how would you write this as an exponent? Well, what you're really saying is this number squared, what number squared would be its root? Weird way to put it. But what you're saying is this number is 1/2. So whenever you write a radical exponent, what you're doing is you're writing it as a fraction where the index is the number in the denominator. Try that again. When you write a exponent that's a radical, the index is in the denominator. A couple of special rules here. When that base is 0, the nth root of any 0 is 0. And when the base is 1, the nth root of 1 is always 1. So those are special circumstances. So this is in your book. It's a way to convert radicals and numbers. And so again, the algebra behind it, for any value greater than 1, where n is an integer and n is greater than or equal to 2, then b to the 1 over n is equal to the nth root of b. That's what we're talking about. This is straight out of your book. You can write it down. These examples are really helpful. Again, 2 to the 1/7 means the 7th root of 2. All right, so let's try this. Let's simplify each expression. So this means the third root of 343. So what number times itself 3 times is equal to 343? Well, that would be 7. Because 7 times 7 times 7 is 343. Now, this is really going to help you get your times tables down. But if you want to do it on a calculator, here's how to do it. Let's see if you can see my calculator there. All right, I'm on a blank screen. What you're saying is the third root. So if you want to write that, you can do it this way. 343 to the power. I'm using this to the power button. Where is it? Right there, to the power button. To the power, and then use parentheses 1 divided by 3. Voila, 7. So down here on these two other problems, it says 32 to the 1/5 means fifth root of 32. And this one says the square root of 9. Well, the square root of 9 is 3. The fifth root of 32, what number times itself? 5 times is 32. Well, that's 2. And you add those together, and you get 5. So what I'd like you to do now is try these first 6 problems on the back of your sheet. At the very end of today's program, I'll give the solutions to Miss Vanessa, and she can help you through them. So work together, try to do these 6 problems. Go ahead, pause the video, and then come right back. So the next part of this conversation is a fractional exponent can have a numerator other than 1. For this point, we've been saying 1 over 3, 1 over 7, 1 over 5. But now take a look at this example. So what we're saying is any number to an exponent can be rewritten a number of ways. So what we're saying is b to the 2/3 is the same as multiplying these 2 exponents together. 2 times 1/3 or 1/3 times 2. So the way of thinking about that is, oh wait, in this case I'm going to take the cube root of a number first and then square it. In this case, I'm going to square that number and then take the cube root, right? You'll notice that these 2 statements are exactly the same. And again, this is straight out of your book. So you're saying the definition of b to the m over n. When you have a number raised to a power that's a fraction, the numerator is what you're raising it to. The denominator is what you're taking the root of. All right, and we'll go through some examples here and show you what it really looks like. So the first one, this says 81 to the 5/4, and so another way to write this is 81 to the 4th root of 81 to the 5th, or you could say 81 to the 5th, all of that to the 4th. So what comes to mind for me is, okay, well, I'm going to do the easier one first. I'm going to try to simplify this first. So really what I want to do is, what's the 4th root of 81? What number times itself 4 times is 81? Well, that number is 3. Now I'm going to take 3 and raise it to the 5th power. So 3 to the 5th power. And again, I'm using the caret key. You see that? The caret key on my calculator, 3 to the 5th. And of course, that's also 81 times 3. So that's 243. The second one here, again, I try to do the roots first. I think it just makes life simpler. But you can also put it straight in your calculator if you're doing it that way. So 3125, the 5th root of that is actually 5. And then I'm going to raise it to the 2nd power. Mr. Walker, 5 to the 2nd power?
5 to the 2nd power is 25, isn't it?
25.
English teacher!
Even English teachers
nailed it!
Can do it. It is. Hey, welcome back. So now that Mr. Walker walked us through that example, no, Ms. Brazier, that's fine. That's all. They like that kind of stuff. Please simplify these 6 problems right now. Work together. And again, at the very end here, we'll show you the solutions. Pause the video if you need to. Okay, we're back. Now, remember this radical sign always indicates the non-negative square root. So when you simplify variables that contain a radical sign, such as the square root of x squared, the answer cannot be negative. But x may be negative. What in the world does that mean? Therefore, when you simplify something like that, you're always going to use the absolute value. So what I'm talking about here, without getting too much into the math theory, is if you have a number like 9, and you say, what's the square root of 9? Well, technically it has 2 answers. It could be 3 or negative 3, right? Negative 3 times negative 3 is 9. What we're going for here is right now, when you take the square root of something like x squared, we're always assuming just the positive version of it. So whether you don't know, when it's even, it's got to be positive. When it's odd, it could be negative, and you'll see how that works out here in a little bit. All right, let's just jump right into this. It says simplify. All variables represent non-negative numbers, okay? Which means these have to be positive values. The first one, what you're really saying here, you can rewrite this several ways. You could say the fourth root of a to the fourth times the fourth root of b to the 20th. Another way to write this as a fractional exponent, the rational exponent is this. A to the 4 over 4 and b to the 20 over 4. And then this truly is a matter of simplifying each one of these expressions. If you do it this way, what's the fourth root of something to the fourth? Well, that's just this. And how many groups of b are here? How many groups of 4? Well, there would be 5. So the other way to do that is, hey, a to the first, b to the fifth, a, b to the fifth. Sweet. Now this one down here, don't fret. Again, we're going to distribute this one here and here. And this also means it's implied to the second. So we're saying x to the 6 over 2, y to the 4 over 2, and y to the 2 over 2. I'm going to move myself out of the way here. Let me get myself out of the way. Now here, x to the 6 over 2 is really just x to the third. Okay, y to the 4 over 2 is 2, and y to the 2 over 2 is 1. Now when you multiply, again, when you multiply two variables together, you add their exponents, right? So y to the second times y to the first is just y to the third. So I just encourage you to treat all these problems like they're puzzles, to not get too caught up, but to try to learn some of the mechanics of them. And they're really not such a bad thing. So here's the game. Now I want you to try to do these problems right here. If you need to work them out on the board, Simon is here to help. He can help work through them with you. And of course, there's also, can't leave the day without a word problem. You guys have a great day. Hope this helped out. Please ask any questions to Simon or Miss Vanessa. And look forward to seeing you back in class on Friday.